So today's lesson we're doing rational exponents. And basically I gave you guys a quick introduction to it yesterday, where if you have an exponent in the form of m over n, where both of those numbers are integers, they don't have decimals in them, okay? And n is not 0, they are rational exponents. Okay? So there's two ways you can look at it. For any non-negative real number x, a positive number integers m and n, you can look at it like this. You can have x to the m over n is the same thing as x to the 1n to the mth power, or the other one. So for instance, I could look at x to the 2/3. That's the same thing as saying x to the 1/3 to the second, right? It is also the same thing as me say x to the second to the 1/3. Okay? Because if you remember, when you have exponents to a power, you're multiplying the power. You know, it's a power to a power. So 2 times 1/3 is 2/3. Okay, 1/3 times 2 is 2/3. Yeah. Yep, it's also the cube root of x squared. Okay? Now, whatever way you could do either way, you could either take it to the power, the exponent, the numerator, or you could take the root of it first. Whatever way makes it easier for you, that's what you're going to do on all of these. Okay, so you're going to want to go down to the first example. Okay, so I can write this as 64 to the 1/3 to the second. Now I'm choosing to take the third root of it first because it makes it a smaller number. Then I'm going to square it. I'd rather square my smaller number than square the 64. Okay? Yeah. Yes. So the third root of 64 happens to be 4. If you take that to the second power, it's 16. The third root of 64, it's like saying third root of 64 to the second power, right? The third root is 4. So 4 times 4 times 4 is 64. You will be able to, yeah, pretty much be able to use a calculator. I know, but if you didn't have a calculator available, this is what you would do, okay?
You would get the same answer if you took 64 squared and then...
You would get the same exact answer if you did it the other way, where if you took 64 squared and then take the third root.
Yeah.
Yep. Okay, so the same thing is what 100. Okay, so I could take 100 to the 1/2 and then take it to the third power. What is the square root of 100? 10, right? So it'll be 10 to the third, which is 1,000. Yes.
So would it be like, is it easier to take like the x and then the 1 over n first and then multiply by the m?
It kind of depends on the number. If you happen to know what the, taking it to that power is first, the numerator first, you could do it that way. It's kind of up to you which way you want to do it. So do whatever's easiest. Okay? All right. Now we're kind of switching gears. This is kind of different because we're going to be thinking about some music here. And I know I have lots of musicians in this room. So this should be interesting to a few of you. Okay. The Pythagoreans discovered a simple property relating different notes produced by strings instruments. If the length of the vibrating part of the string is cut in half, the tone is raised an octave. Most of our music today divides the octave into 12 notes, called a chromatic scale. Let G be the factor that relates the length of the string for two adjacent notes like C and C sharp. So then, we can write this. G to the 12th is equal to 1/12 of the scale.
Wait, what's the G?
G is the length of the string. The factor that relates the length of the string.
Oh, yeah.
Okay? So I want to find out what G is. So what I want to do, oh, I'm sorry, this should be a 2. 1/2. It's because it went up a half a note. C to C sharp. Sorry. Yeah, G to the 12th is equal to 1/2. We're just talking from C to C sharp.
This is not necessarily true.
Because it's a half step, right?
A half step.
But like on a string instrument like a violin or a cello, they're all the same length. And it's just a matter of untitled,
They're different, yeah, they're different lengths too, actually. A cello is a lot longer string than a violin.
No, but from string to string on the cello.
Oh,
No, it's a piano.
They're the same.
yeah, yeah. It's all proportion.
You also
So like their thickness? Like bass string.
Our problem here, we want to find what G is, and in order to do that, I'm going to take 1/2, okay, to the 12th. Okay? Yeah, to the 1/12, because the 12th root of G, this, and the 12th root of this. That ends up, if you put that in your calculator, that ends up being 0.944. Okay? And what it is actually telling us is that to move to the next note, the string must be shortened. Yeah, 1/2 to the 1/12. The string must be shortened to 94% of its original length. To go up to the next note, so it's like a half step. So this could be a good May term project.
So like say you have a string about like 100 inches long.
I'm thinking about for next year for those of you that are in. Suppose that a string that is 650 millimeters long plays a C. Then to play E, which is 4 notes higher on the scale, the vibrating part should be. And so yeah, it'll be 650 times 1/2 to the 4/12, because we went up 4 notes, right? Right. So if you were to put that into your calculator, it's going to end up being about, the string should be about 516 millimeters long. Yeah, you could do that. Yep.
That could be 507.
Yeah, what's your question?
So you said that.
Okay, it says G that is 7 notes above C sounds very good with C because the strings are close to vibrating together. Okay? This is because the ratio of the lengths of the strings are very close to a simple fraction with whole numbers in its numerator and denominator. What is the ratio? Okay, so the first one, if we're going to say, I'm going to say the length of C is just X. We don't know what it is. Okay? And then I'm going to say the length at G. I should make that a capital G, but I didn't. So the length at G is going to be X times 1/2 to the what power? 7/12. Very good. Okay. So what we are looking for is it says what is the ratio between these two strings. So I'm going to take X times 1/2 to the 7/12 over X. What cancels out there? The X does, right? So it's just 1/2 to the 7/12. Yep, so if you put that in your calculator, you're going to end up with 0.6674, which is almost like saying 2/3 if you were to put it in a regular fraction. It's pretty close to that. All right, so I'm going to pause this. I want you guys to look at the next problem, which is 2b. It's the same kind of thing. Give it a time to do it yourself. And then we'll see if you got the same answer I did. These are the basic rules of exponents. You guys should remember this from before. So this would be x to the what power? Not a plus b, a times b.
I thought it was only times if it was x to the a to the b.
Yeah, it is. That is a to the x to the b. So this one, a times x to the a. Yeah, this one's a plus b. Okay? What's this one? Yep, this one's a minus b. How about this one? Yep, xb, y to the b.
And then same xb over y.
Yep. All right. The zero exponent theorem. If x is any non-zero real number, x to 0 is 1. Okay? So anything to the 0 power is 1. Mrs. Seaver to the 0 power is number 1. Number 1. Yeah, we'll talk about that in just a second. Here we are. Okay, negative exponent. Anytime you have x to a negative number, it ends up being the fraction of itself. It's the reciprocal. Oh, that doesn't affect it.
So it's like negative 1 to the 0 is still 1?
Yep, negative 1 to the 0 power is 1. Okay? How about negative 1 to the 0 power like that? It's a negative 1. Why?
Oh, because opposite of.
Notice that that negative is included to the 0 power. But this one, it doesn't have a parentheses around it, so that 0 only applies to the 1, not to the negative. Okay, so you might want to write that down.
But like 2 to 0, 4 to 0, it's all 1.
All right, so let's look at A. We have 49 to the negative 3/2. Okay, I like to do this as, first of all, you got that negative to deal with, so I'm going to go ahead and put it in its reciprocal form to get rid of that negative. Yep. Okay, now going from this direction, I could take the square root of it to get rid of that 1/2 part of it, okay? So what's the square root of 1 over 49? Yep, so that'll be 1 over 7 to the 3rd power we still have left. And what's 7 to the 3rd power?
343.
Yep, 343. All right. So on this one, notice that the numbers are really large. So again, so I would like to take the 3rd root of it first before I take it to the 4th power, because otherwise it just gets really big. Okay, so because I have this to the 4/3 power, I'm going to take it to the 3rd root first. Okay, so the 3rd root of 64 over 729 to the 4th power, right? That is the same as saying 4/9 to the 4th power, which happens to be 256 over 6561. I don't think you can. Okay, this one says write this number as a power of 2 instead. I want to change that 1/2 to a 2. What would that do to my exponent? You're on the right track.
2 to the 12 still?
Nope.
What does it mean to a positive power?
I want to make this equal to something 2 to the something power instead of 1/2. How would I make this into a 2 of the something power? Nope. Who somebody said a negative? Yep, this will become a negative n over 12. A little tricky, huh?
Well, because if you can go one way, then you can go back. Did you see how she went one way at A? She made negative 3 over 2, the exponent, into a positive by putting 1 over 49. It's just going the opposite direction.
Mm-hmm.
So when you take like the opposite of the exponent, you can take the reciprocal of the lower number?
Yeah.
So like,
So let's look at this one. This one's also to a negative exponent, right?
So 9 to the...
So this is the same as saying 9 to the 2/5.
what if it wasn't just 1 over 9? What if it was like 4 over 9?
There'd be 9 over 4.
And it says power of 3.
Okay, so we want to make this to a power of 3. What's 9, though, in terms of 3?
You take the square root of 9.
Yep. So this is like saying 3 to the second to the 2/5, right? Okay, so what happens to my power of a power? Nope, multiply. So 2 times 2. Yep. Mm-hmm. All right, so it says find the volume of a cube with a surface area of 105 square inches. So we know that a cube is like a dice, right? It has equal sides all the way around, right? And each side is an S, length S. So the volume of that is going to be V equals S to the third because it's length times width times height. So if we're wanting to find the surface area of this cube, we know that one side of the cube is what? S squared, right? So if the surface area of one side is S squared, how many sides do we have?
6.
So it'll be 6S squared.
And you just do 105 divided by 6? Because the total surface area
Yes.
altogether is 105, and then you have 6.
So we're getting there. Yes. Okay. So first of all, I know that the total surface area is 105, so I'm going to put in 105 for my surface area. Okay? And then I need to get S squared by itself. So that's going to be 105 over 6.
So you would take the 6 out first, not the square?
Right.
Do the simple one.
Yep. So now I need to get S by itself. Square root of that. So I'm just basically going to say 105 over 6 to the 1/2 power. Yep, that ends up being 4.183 equals S.
Wait, why do we have to have a 3?
Oh, you don't. I just took it out of
Oh,
Okay? So what is my volume then?
It would be 4.18 cubed.
Yep, 4.18 cubed.
What is S?
S is the length of a side. Okay, so that would end up being 73.21 inches cubed.
Wait, why would you multiply by 3?
So part B says express the volume V as a function of its surface area. So we want to put V in terms of SA instead of S's. Okay? So in order to do that, I still need to solve. I'm going to take this SA equal to 6S squared. I want to solve for S.
So S is
So in terms of SA though, okay? So this will be SA divided by 6 to the 1/2 power, right? If I were to solve for S. That's taking a bunch of steps at once there. But do you guys see how I got there? So I divided both sides by 6. Then S is squared still. No, you gotta divide by first. You do the exponent last.
I know, but like the square root, why
So now I know that my volume equals S to the third, right? I've already found S here. So I'm just going to insert that Like this, right? So what happens to my exponents here? Yeah, so now my final answer is going to be SA over 6 to the 3/2. And that's why I leave it in fraction form. It's just easier in the end. Okay? We are down to the last one now today. A sphere with a diameter d has volume V equals pi d to the third over 6 and a surface area of S equals pi d squared. Express the surface area as a function of volume. So what we need to do is get S, and we're going to solve for d with the surface area one first, okay? Wait, no. We're expressing surface area in terms of volume, so I need to solve for d in the volume. Okay, yep, times 6 for both sides. So then we have 6v equals pi d to the third. Now what? Divide it by pi. Yep, to 1/3. Okay, now I'm just going to replace the d in this one. So it'll be S equals pi d squared. So it ends up being pi times 6v over pi, the 1/3 squared, right? So my answer on this one is going to be pi times 6v over pi to the 2/3.
Is that pi on the bottom?
Yeah, it's a pi. Sorry, I didn't quite write it out again.